Hello, this is the very first lab of CS147. Uh, that is nothing much. We'll just do a tool installation which we'll use for experiments in the computer architecture area. And we'll use something called simulator. If you're not familiar with that concept, just to make you on the same page, simulator is a software program which virtualizes the real-life operations or real-life experience. For example, most probably many of you have heard about the flight simulator. It is very popular among the pilots of commercial area, even in the military area. It's basically a software program along with interfaced with some like real life equipments that we find in a real airplane cockpit. So it recreates that cockpit environment. Okay, and there is a big display in front of the user, which kind of gives a feel that you are sitting on a real airplane cockpit and you were actually flying an airplane without even operating a real airplane. People uses that to start learning the flying with the airplane, because that is much more safer route. Because like if you for the first time you just got into the airplane and someone tells you, hey, go and fly that airplane, it's very possible that you will do some mistake, and on air a mistake is fatal. So there is a very high risk, high cost associated with operating into a real airplane when you will start learning. So people usually takes this route, like they uses this simulator, flight simulator, gain certain experience on certain situation, what to do in some problem, this and that, and then once they feel confident, and at least their instructor feel confident about that, okay, now they are able to actually try an real airplane, they can actually go and start operating a real one. So similarly, in the digital world, like when you do an hardware design, hardware chip design, we actually create circuits, describe circuits in terms of certain languages, but we don't directly, like describe that circuit or create the circuit and then go and print onto the silicon and create the real IC chips and stuff like that, and then test if this works or not. That is very expensive route. Like putting one design onto a silicon is very expensive. So what we usually do, similar to the flight simulator, we describe our circuit and run simulator on that to see the behavior of the circuit. If it is, we can test it, like whether it is working properly accordingly whatever we intend to do with that chip, and so on and so forth. Once we are satisfied with that simulation result, simulation observation, that whatever we wrote, whatever we created as a digital circuit, if it works, behave properly, works as intended, then only we go and print it on a real silicon, and then of course then we test that silicon and to see that if it is working properly again on the silicon. But if we go through that route, like when we simulate first, make sure it works properly in the simulation, the probability of making it into a real life is much higher. Like if it actually passes through the simulation, real life operation of the chip will probably 99% will go through, will pass that. So this is the standard way that chip design engineer does, and we'll do the same thing in our to see some computer architectural behavior, how things works inside, and so on and so forth through the simulation, so that we'll get a feeling of the real life operation of a processor. This will also benefit you in terms of your resume, that you can put that okay, this is a commercial tool, simulation, hardware simulation tool, that you know how to do, how to operate, how to write program on that, and that will benefit in some terms, especially if some of you want to go into this chip design and digital design area. That will help you a lot. So this is the tool we'll use mainly in our course. This is ModelSim from Mentor Graphics. There is a student edition. The thing is that the student edition is like for Windows only operation. I understand that many of you uses non-Windows platform like maybe Linux, maybe Mac OS, but this one unfortunately only available on the Windows. Search in the Google for the ModelSim Student Edition. It will give you the link to that. You can go there, download it, install it, and at the end of installation, which is very important step, it will pop up a web browser and pop up a form. Basically, you need to fill up that form, get the license, and install the license in the installation area. Without the license, it won't work. Okay, so last step is very important. So when it do a finish, you click the finish. After that, it pops up that web browser. I'll show you how it works. So if you think that you don't want to use a Windows tool or something like that, there are alternatives though. There is a ISE Webpack from Xilinx, Quattros from Altera, which is Intel now most probably, an ActiveHTL from Altec. But be aware, these tools are for the FPGA implementation. There is a whole sort of hardware, programmable hardware thing, and these tools are mainly targeted for that. They have a simulation component, which is kind of a side feature of them. As a result, usage of these tools are a little bit trickier than the ModelSim. ModelSim is very straightforward interface, intuitive interface, and since simulation is the main objective, you won't be distracted with many other things for setting up. These tools is a FPGA programming tool, so that is their main purpose. Simulation is a side feature. As a result, it's actually a little bit complex for all this setting up and stuff like that. But of course, we can walk through that if you need. Also, there is another way that usually people does who loves to stay as a non-Windows platform. We can do either the dual boot operation, like we can partition our disk or install Windows on one partition. Another thing is a virtualization. Again, like there is a free software called VirtualBox, which is from Oracle. The VirtualBox is a software which allows us to install the Windows onto as a guest operating system on your Unix platform, Mac or Red Hat Linux platform. And then once you do a VirtualBox installation of the Windows, then you can go and install the simulator of onto that virtual environment. The only point to be noted in the VirtualBox environment is that if you are running an old PC or laptop, which is like has very low memory or less processor speed, things is going to be slower. On newer laptop or PC, it's not a problem. I have used that, and it to install the ModelSim tool, what you can do in your browser on Google, just search for ModelSim Student Edition. It will give you the very first link, will give you the ModelSim page. You download. I have already downloaded this part, so I'm not just showing the download, but you click on this, it start downloads, and practically it will give you let's see, this one, ModelSim P Student Edition. So you double click on that, and it basically open up. You do a run, and it just goes and unpack. It's a standard installation process practically. Yes, next, next. Then it goes and start extracting the tool for you. And at the end of the installation, it will pop up a web browser with a form which you need to fill up to get a license. This license, I believe, are 3 months valid. So it should cover up the semester. Let's see. So we have, like, let's say starting from September, October, November. Maybe towards the end you need to do an reinstallation process like this to get another license. So it might cover just barely, or if you see certain problems, suddenly some problem is coming up, it cannot run, it says that okay, license is expired, so basically you reinstall the tool and get another license. Okay, so it's done there. Yes, I want to do include the path of the ModelSim into my environment. Do a finish. So after this is the important step. Okay, you go and fill up your all this field, name, email, etc., and then you will, on the email, you will get a file called student license.dat file, which I have downloaded already. Or let me see. No, actually I haven't. Let me just go to my email and so this is a file, so you need to download that file. Download it. Okay, so I clicked probably twice on that part, but anyway, that's okay. So what to do, and it also has instruction where to put that thing. So this is a student license, and I believe, let's say I installed the ModelSim in program, no, here as a C drive directly, right? So you can choose your folder, no problem. So it says that the folder which contains this specific directory, win32p underscore edu, you go and need to install this file to this directory. So I already did that anyway. For you, I'll just show. So drag and drop here, move and replace. So once you have done this, you're ready to go. So you'll notice it will create a shortcut on your desktop. So you double click that, it will go and fetch that license, fetch the tool. You can do all this now simulation, like you can write, it is basically integrated development environment, which means you can go and like start writing the hardware description. We'll learn a little bit on that, how to write things in a specific language called Verilog. But anyway, so basic point is that you can do writing, just to do write in your IDE based programming environment like Java editor or Eclipse. It's something like that. You just write it, compile it, run it. Okay, so I think the next lab we'll see more concrete example of a real example of a digital circuit and a simulation. So till then, just good luck with your installation. If you have any problem, let me know. I can help you definitely in my office hour. So main point is that we will use ModelSim. There are certain alternatives which is a little bit complex to use. I would recommend to go for a virtual box environment if you don't have a native Windows environment. That way we can get jump start on that.